In this question, you're asked to prove that adjoint of A is equal to det A whole power n minus 2 times A. Det of adjoint of A is det A whole power n minus 1. Det adjoint of A to the power m is adjoint A whole power m. Adjoint of AB is adjoint of B times adjoint of A. So now, let us start with the result B. So let us first prove that det of adjoint of A is det A whole power n minus 1. It is very easy to do. So we can start with this. A times adjoint of A by det A is equal to I, right? A times adjoint of A by det A is A inverse is equal to I. This implies A times adjoint of A is equal to det A times I. This implies if you apply det on both sides, det of A times adjoint of A is equal to det of det A times I. This implies we know that det of A into B is equal to det A times det B. This det A times det of adjoint of A is equal to, so det of det A is a constant number, right? So det of K times I is K power n times det of I, which is equal to 1. Identity matrix has det is equal to 1. So this implies det of adjoint of A is equal to det A power n by det A, which is det A to the power n minus 1. So this is the logic behind the result det of adjoint A is equal to det A power n minus 1. Now let's go to our first result. So let us try to prove that adjoint of adjoint A is det A whole power n minus 2 times A. Now, A times adjoint of A, matrix A times adjoint of A is equal to det A times I. This is what we have already done. Now what I do is, I'll replace my A with adjoint of A. So let us, any matrix into adjoint of the matrix is equal to det of that matrix times I. So replace A by adjoint A. So adjoint of A times adjoint of adjoint A. Wherever A is, I am putting adjoint A. Adjoint of adjoint A is equal to det of adjoint A times I. Now what I do is, I'll pre-multiply both sides with A. So A times adjoint of A times adjoint of adjoint A is equal to det of adjoint A times, I'm multiplying with A times I is A, because A multiplied by I will give you A itself. This implies, so what is A times adjoint A? It's nothing but det A times I. So det A times I times adjoint of adjoint A is equal to, so what is det of adjoint A? We have already derived this. Det A power n minus 1 times A. So I times adjoint of adjoint A is same as adjoint of adjoint A. One det A gets cancelled here. So det A power n minus 2 is left out. This implies adjoint of adjoint A is equal to det A power n minus 2 times A. So det of adjoint A is a number, hence it is det A whole power n minus 1. Adjoint of adjoint A is a matrix. So you have a number times a matrix. So det A whole power n minus 2 times A is adjoint of adjoint A. So now let us go to third result. Adjoint of A power m is adjoint A whole power m. Now, prove the third result. Let us start with a power m times adjoint of a power m by det a whole power m. Right? Det of a power m is det a whole power m is equal to I. So adjoint of a power m by det of a power m times a power m is equal to I. This implies a power m times adjoint of a power m is equal to det a whole power m times I. So now what I do is I'll multiply both sides by a inverse power m. So this implies a inverse power m times a power m times adjoint of a power m is equal to, so det a whole power m times a inverse power m. So this implies a inverse power m times a power m. So m inverses will cancel out m is, so you get I as the answer. So I times adjoint a whole power m is same as adjoint of a power m is equal to, so you have det a whole power m, and what is a inverse? A inverse is adjoint of a by det a whole power m. So det a power m and det a power m gets cancelled, so you get adjoint of a whole to the power m. So adjoint of a power m is adjoint a whole to the power m. Next, let us try to prove that adjoint of AB is adjoint of B times adjoint A. So let us start with the proposition AB times adjoint of AB by det of AB is equal to I. So AB, and this is the inverse of AB. So AB times adjoint of AB by det AB is equal to I. Now, we have to prove that adjoint of AB is adjoint of B into adjoint A. So now what I do is I'll multiply both sides by AB whole inverse. So AB, so I'll multiply by AB whole inverse times AB times adjoint of AB by det AB is equal to AB whole inverse. Now AB whole inverse times AB will give you I. So I times adjoint of AB is adjoint of AB by det of AB is det A times det B is equal to. So what is AB whole inverse? B inverse times A inverse. So this implies adjoint of AB by det A times det B is equal to. So B inverse is adjoint of B by det B, and A inverse is adjoint of A by det A. So det A, det B, det B, det A, it's cancelled. So you get adjoint of AB is equal to adjoint of B times adjoint of A. So this is how you have proved the fourth result. So similarly, if other results are given, if you are asked to prove the other results, you can use similar process to get the answers. Thank you.